Let's look at trig functions of general angles. Now, since I'm going to be using a point, x comma y, let's go ahead and draw an xy plane, x-axis and y-axis, then label some arbitrary point, x comma y, then connect that point to the origin, and then extend that line down to the x-axis, and I have a right triangle. So let's call this side x and this side y. Now the hypotenuse I want to call r. So instead of using a, b, and c as I have been, if you've been watching other videos of mine, I'm now going to use x, y, and r. This is actually going to make the previous videos and sections that you may or may not have been doing a little bit easier to understand. And so I have this distance from the origin to the point, and instead of using the Pythagorean Theorem as a squared plus b squared equals c squared, I'm now going to use x squared plus y squared equals r squared, because x and y are still the legs. Now to find that distance r, I'm going to take the square root of both sides. Those are going to cancel out, just leaving r, and then I have my square root of x squared plus y squared. Now you don't have to memorize that, because you can always use a little picture to help you figure it out. But the main thing I want you to be aware of now is that my definitions, I'm not going to be using a, b, and c anymore. I'm still going to be using opposite over hypotenuse. For example, the sine of theta, if I call this theta, because of the initial side being on the x-axis and the terminal side being in the quadrant, the sine of theta is opposite over hypotenuse, which is y over r, using these letters. And then the remaining 5 trig functions come from the exact same definitions as before. But the main thing I want you to be aware of is now to think of sine as being a y and cosine as being x. So if you see sine, I always think of y's. It doesn't actually equal to y, but it's a good way to think of it. Sine is y, cosine is x. It's going to make your life a whole lot easier. Sine is y, cosine is x. Just memorize that, get that in your head, and you'll be good to go. And now just to show you where the tangent comes from, tangent is the same as sine over cosine. Now if I actually use these definitions as they are, sine is y over r, cosine is x over r, and these r's cancel out, leaving the y over x that's given to be, and that we now know it is. We also could have just done this. Since tangent, I want you to think of it as sine over cosine. Well, sine is y and cosine is x, y over x. I'm telling you, it's going to make life a whole lot easier. And then cosecant is just the flip of sine, secant is the flip of cosine, and cotangent is the flip of tangent. But sine and cosine, if you know sine and cosine, you know everything. Now let's do an example. And I'm going to use x, y, and r, because this time we're given a point. So what I want to do is actually draw an xy plane. I'm going to label this point, call that -3, call that 4, and there's the point. So I'm going to extend it to the origin, then extend it down to the x-axis, and now I have a right triangle. I'm going to call that side r. This side is actually 3, and this side is actually 4, but I want you to keep note that that's -3. And furthermore, that is our x, and that is our y. So once we have our r, we're going to be good to go. So we need to find r. So I'm just going to use the Pythagorean Theorem, and we're going to do 3 squared, or -3 squared, but if you do use -3, put that in parentheses, plus 4 squared equals r squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Square root both sides, and we now end up with r equals 5. So I have x, I have y, and I have r, and I actually am ready to go ahead and do the work. So I'm not going to call that q, I'm going to call that theta. And this is our theta. So sine of theta, we can use y over r. We can still use opposite over the hypotenuse, which the hypotenuse is now 5. But If you have x, y, and r, let's just go ahead and just use those. Y is 4, r is 5. See, now it's just substitution. Cosine is x over r. X over r. X is negative 3, and r is 5. And then tangent is y over x. Y is 4, x is negative 3. Now I don't want to put the minus sign on the bottom. I want to put it on the top or on the side. Some systems don't like it on the bottom, so just be aware. Now let's go ahead and do cosecant. And that's just the reciprocal of sine. So it's r over y. R is 5. And y is 4. Notice reciprocal. Secant is r over x, which just means take the negative 3/5 and flip it over, put the minus sign on top, so it becomes negative 5/3. And then cotangent is x over y, which just means take the negative 4/3 and flip it over, put the negative on top, and that's how you're done. So once you have r and you're given x and y, and you know these definitions, you're good to go. Just remember, sine is y and cosine is x. Everything else follows from that. Now I want you to look at this information. It's talking about when tangent and secant and cotangent and cosecant are undefined. Now everything else that we're doing, that we've been doing, it's going to hold true. Nothing's going to change. All the same identities will hold true. But I want to look at an xy plane. So we're actually going to look at points on the x-axis and on the y-axis. So I'm going to pick an arbitrary point on the x-axis, and let's just call it 1, 0. Now, get ready for this. The 0 is a big deal. It's a really big deal. Notice the 0 is actually a y value. So let's think about where we have y values. Well, the sine, like I told you before, we want to associate with y values. So that means we also want to look at cosecant. For now, cosecant is the same as 1 over sine. Now if you think of the sine as being the y value, which is 0, that means we have division by 0 on the x-axis. If the point lies on the x-axis, that means that you can't divide by 0, so that's undefined. That's why we're saying that cosecant is undefined when the point's on the x-axis. Where else do we have sine involved, especially in the denominator? Well, let's think about it. We have cosine over sine, because that's the same as cotangent. And so if you think of cosine as being the x value and sine being the y, we once again have 1 over 0, which is not possible. So that's why cotangent is undefined. So here's how you really are thinking about. Take a point on the x-axis, which is 1, 0, which means you have x and y. So here we have cosine will be 1, sine will be 0. Tangent will be 0 over 1, because that's y over x. And that's fine, because an answer of 0 is fine. But the problem is when we have 0 on the bottom, like with cosecant, that's 1 over the y value, which is 0. Not possible. Cotangent is x over y, which is not good. It gives us division by 0. Now let's look at an arbitrary point on the y-axis, call it 0, 1. And if you think about it, cosine is 0, sine is 1. So sine is fine, cosecant is fine. The only thing I have to worry about is when I have a 0. Cosine is 0, that's fine. But what about when I have cosecant on the bottom, like underneath a 1? Well, that's the same as secant. And the cosine at that point would be 0, and that's not possible. And then if you think about sine on top, cosine on the bottom. Sine we would call 1, cosine we would call 0. Well, that's the same as tangent. And that's not good either. So that's where we get tangent and secant are undefined when the point on the y-axis. Keep in mind, think x, y, where sine is x, or sine is y, and cosine is x. You might want to think of it like this: cosine, comma, sine. X, comma, y, cosine, comma, sine. I'm trying to get you to see some ways of really making this a whole lot easier to understand. Now let's talk about coterminal angles. Now, you're going to see some ugly notation. It's just set in 360s all the way around. 2 pi is also all the way around. You can keep on going forever and ever and ever. Let me show you what I'm talking about when we do coterminal angles. Let's look at this nice plane. And let's just pick an arbitrary point. It doesn't matter. So if I go all the way around, and this, by the way, is 0 degrees, is where I'm going to start. If I go all the way around, that angle is also 360 degrees. But here's the thing. I can keep on going. If I go around again, that's 720 degrees. I can keep on going as many times as I want. Well, all these angles actually have the same measure. They actually mean the same thing. They have the same trig values. It doesn't have to be there either. Let me show you. What if I just go from there to there? Well, that would be a 90-degree angle. Now if I go around again, and I'm just not being exact anymore, well, that's the same as what? That's the same as 90, and I went around 360 more. That's 450 degrees. It's the exact same thing. I can go around another 360. So every time I go around, I'm adding 360. Or, we know that's the same, 90 is the same as pi halves. So that's the same as pi halves plus 2 pi. And 2 pi is the same as 4 pi halves, which gives us a grand total of 5 pi halves. Do you want to see an easy way to find this 5 pi halves without actually having to do any addition? Okay, I'm going to show you. First thing you have to know is that the 90-degree angle is the same as pi halves. So that means I can count by 1 pi halves. So this would be 2 pi halves. This would be 3 pi halves. This would be 4 pi halves. And then back around puts me at 5 pi halves. I'm just counting by 1 pi halves. That, to me, is the easiest way to do this. Now, that's something else I want you to be aware of. We can also go the opposite direction. That's what we're going to do. Let me erase all this so it won't get in the way. So if we go opposite direction, or clockwise, that's negative pi halves. And let me right now just call it negative 90 degrees. So it's like we're drawing an angle. And we're going counter or clockwise. That's a negative 90 degree angle. And it's also the same thing as if we were to go clockwise. That would be, well, let's count 0, 90, 180, 270 degrees. It's the same thing. So you can also do a negative 90 degrees or 270 degrees positive direction, or we could go clockwise and make it the same thing as negative 450 degrees. If we go this direction, there's negative 90, and all the way around again is negative 450, because that's negative 360 more. Hopefully that makes some sense. And we'll do some examples along the way, and I'm going to show you how you do a lot of this just by counting. So we're going to use a coterminal angle to find the exact value of sine of 405. So the first thing I want to recognize is, and there really isn't a whole lot to do here once you start to understand this, but recognize if we start here, this is our initial side, and if we go all the way around, and since this is a positive value, I'm going to go counterclockwise, that's 360 degrees right there. So that means I want to go how many more until I get to 405? Well, that's just 405 minus 360, which is 45 degrees. So I'm going to go 45 degrees more, which puts us right here. See that? So you go on, here's what you're doing. You're going all the way around to 360, and then you're going further because that's the same as 45 degrees more. So what that means is that the sine of 405 degrees is actually the same as the sine of 45 degrees. And if you remember what the sine of 45 degrees is, it's the square root of 2 over 2. And that's all you're doing. Use a picture if you need to, or just think about 360 degrees or 2 pi or whatever the angle is in. But that's it. Now this other information is you may or may not like. I don't particularly like how this is set up, but this is one way to think of it. This is how some books look at it, so that's why it's here. Now once again, some books use A and B. I actually prefer to use X and Y, so I'm going to use X and Y instead. But I don't even really have to look at any of that. But this is how some books do it. Let me show you all you really have to do. Remember, my suggestion is remember that sine is Y and cosine is X. So, in this first quadrant, what do we know? We know that we have a positive X and a positive Y. Now in the second quadrant we have a negative X and a positive Y. Third quadrant we have a negative X, negative Y. And the fourth quadrant we have positive X, negative Y. Now I can easily do this. That means that if I think of X as being cosine, that means we have a positive cosine and a positive sine. Second quadrant, I have a negative cosine and a positive sine. Third quadrant, they're both negative, negative cosine. Let me make this just a little bit thicker. And negative, wasn't much thicker, negative sine. Here I have a positive cosine, and I have a negative sine. Just thinking X's and Y's. Now once I have that, I know that cosine is associated with secant, because they're reciprocals, and sine is the reciprocal of cosecant. So I know over here in the first quadrant, secant and cosecant are both positive. In the second quadrant, I have a negative secant and a positive cosecant. Third quadrant, they both are negative, so it's negative cosecant. That's backwards. Should be negative secant. I want to keep them consistent. And negative cosecant. And then in the fourth quadrant, I have a positive secant and a negative cosecant. All thinking X's and Y's. The only thing we have to worry about are tangents. Now tangent is the same, and cotangents. Once I know tangent, I know cotangent automatically. I know tangent is the same as y over x. So all I'm doing is just looking at the signs. Positive over positive means tangent is positive. Now negative divided by positive, or positive divided by negative I should say, means that tangent is negative in the second quadrant, and then third quadrant, I have a negative divided by a negative, which means I have a positive tangent. And then the fourth quadrant, I have a negative divided by a positive, and that's a negative, which means that tangent is negative in the fourth quadrant. I don't have to memorize these if I already know my signs for the four quadrants, and then as long as I remember that cosine is x, sine is y, I'm good to go. And that's what all this is saying. But I don't like to memorize. I like to see it. I like to visualize. So here I go with an example. Let's identify the quadrant with sine of theta is greater than 0, which means it's positive, and cosine of theta is less than 0, which means it's negative. Once again, sine you want to think of it as being y, and cosine as being negative. So where x is negative and where sine's positive, so that just means from the origin we're going to go negative and then positive, which puts us up here. Negative, comma, positive, or positive. Not a y, I don't want a y. I want a positive. I just lost it. Where did it go? It disappeared on me. Oh, it's back. So, what quadrant is that in? That's quadrant number 2. By the way, you always count counterclockwise. 1, 2, 3, 4. See, that's all about the signs. Think of cosines being the x and y, and sine being the y's. Now we have reference angles. What that means is that our initial side is always on the x-axis, and the terminal side could be somewhere else. It's going to be somewhere else. And they have the same values, and the signs are going to differ. And we've already talked about the signs, so you don't have to memorize this stuff. And what I really want to do, well, let's just go ahead and do an example or two, just so you can see. Well, we got a few examples here. We got 3, looks like, maybe 4. Oh, it's even better. So let's do these first 3 examples first. They're all similar. So let's find the reference angle for negative 30 degrees. Now I've drawn one negative angle. So let's draw another one. So here's my initial side. It's on the x-axis always. Now I want to find the reference angle for negative 30. So what that means is I'm going to go clockwise because I'm going the negative direction. And that's going to put us down here. So that's going to be negative 30 degrees. To find the reference angle is the positive angle associated with the same initial side. And that's what that says up here. If I can find it. The trig function, the only difference is the reference angle is the acute angle formed by the terminal side and the x-axis. It's actually the positive value, or it could be the negative. Since we're given the negative, what is the angle have associated? The positive angle is associated with negative 30 from that angle to that angle, and we're on the x-axis now, so it's the same as a positive 30 degrees. In other words, what's the acute angle that's close to the x-axis? See that? Find the acute angle that's close to the x-axis. There's that word I was looking for. The acute angle. So I don't want to go that way because that's way bigger than 90. So the reference angle for negative 30 is, well, the positive 30 degrees. Because that's how I can get to the x-axis from that corresponding angle, reference angle. Now, if I wanted to ask you, for example, what would be the reference angle for 150 degrees? That means that we would go way over here for 150 degrees, because that's 90 and then 60 more would be 150. Well, the reference angle is from the terminal side to the initial side. So from there to there, what is that angle? Well, if that's 180 degrees all the way over, that means the reference angle is going to be 30 degrees. And let's say I want to go even further. So let's say that I wanted to use, say, 240. That means I would go way over here, because 240 is 60 more than 180. So that angle is 240 degrees all the way over. So the distance from there to there, what's that angle? Well, that's 180. And 240 minus 180 is 60 degrees. So my reference angle is 60 degrees. So I'm looking for a positive angle. And the reason why we're doing this is because we need the 30, 45, 60. And then from there we can find any trig value. And the only thing we have to worry about then is what quadrant we're in to determine the sine. So now we're going to do these examples. We're going to find the exact value of sine of 150. So if you didn't catch it up here, I'm going to do it again. I'm going to start on the positive x-axis as always. And then I'm going to go 150 degrees. Well, there's 90. And then 60 more puts us at 150 degrees. I have to draw arrows so you know which way I'm going. So we're at 150 degrees. So what that means is that this angle is going to be 30 degrees. And that's 30 degrees in the second quadrant. Got that? And since we're doing sine, sine is the y value. And in the second quadrant, negative positive, sines are, or y values are, positive. So what we're trying to find is a positive value of sine of 30. And what is the sine of 30? It's 1/2. Since it's positive, it's a positive 1/2. And we're done. Let's find the exact value of sine of 510. This is where we're going to use the terminal angle, or the, terminal angle. No, not terminal angle. I'm drawing a blank here. Coterminal angle is what it's called. It doesn't hurt to always go back to your notes. And there we go. I always want to use the right terminology when we do this. So find the exact value of sine 510 degrees. I'm going to start here. And since we're doing 510, I'm going to go all the way around. That's 360. And then if I go 90 more, that's 450. And then I need to go 60 more, and that's 510. Or in other words, you take 510 minus 360, what do you get? 150 degrees. Which puts us right there. And so you may want to think of that as being the same or corresponds to 150 degrees. But the reference angle we're looking at is that angle, which is 30 degrees. And what do you know? We're still finding sine. So we're actually finding the sine of 30 degrees in the second quadrant, which we've already talked about. Sine is the y values, and they're positive up there. So it's going to be a positive answer, which is going to be 1/2. Let's do another one. Let me go down here so we have some more space. Let's find the cosine of 240 degrees. Just to show you. Here's the real way I would do this. Not doing too much thinking. I know that I know from here to here is 180 degrees. Got that? That's what I'm really thinking. And so if 180 degrees, how many more degrees do I need to be at 240? 60 degrees more. And that's the angle I'm going to look at. So cosine of 240 is the same as the cosine of 60 degrees. Now here's the only other thing we have to worry about. We're in the third quadrant. In the third quadrant, our x values are negative. And cosine is an x value, so that means it's actually a negative cosine of 60. That's all I'm doing. And cosine of 60 is the same as sine of 30. Sine of 30 is 1/2, so that's negative 1/2. That's all I'm doing. If I wanted to find the tangent of negative 45 degrees, all I'm doing is I'm going clockwise now, which means I'm going this way 45 degrees. And that's actually a negative 45 degrees. But the angle I want to look at is the positive value of it, because that's the angle being formed here from the terminal side to the initial side. So I want to look at the positive value of it. So it's the same as tangent 45 degrees. But I have to worry about the signs. Tangent is y over x's. Since my y is, or my x is positive and my y is negative, that's negative over positive, which means it's going to be a negative value. Tangent 45 is the same as sine of 45 or cosine 45. Both of those have values of square root 2 over 2. Anything divided by itself is a 1. So that means it's going to be negative 1. And that's all I'm doing. Hopefully you see that. You can maybe do it as fast. Hopefully you can do it faster. Now let's look at this example. This may be a little bit different. May look a little different, but it's really not. We're given cosine of theta is 0.7. If you notice, that's a positive 0.7. So let me write that in there. Positive. Internet's acting up. There we go. Positive 0.7. So we want to think, where's cosine or the x values positive? Well, they're positive here and then positive there. So let's just say if we pick a point up here to where we have an angle that forms, that pi means we're going to go 180 degrees, which is over 2 quadrants. So what that means is we're going to go from here and then we're going to go 90 more and 90 more, which now puts us down here. And that's our theta. Or if you were to start with theta down here and then move it 180 degrees, it'll be up here, but it doesn't matter which one. Let me do that again, because I'm not convinced that I explained it well, because I'm having issues with my computer. Slow. So let's try this again. I'm going to pick a theta. It's positive. I'll either use the first quadrant or fourth quadrant, because that's where the x's are positive. So if I just pick the first quadrant, there's my theta. And this is the angle that's formed. Now, plus pi means pi is the same as 180 degrees. So if I rotate or flip twice, however you want to think of it, if I go 180 degrees, that means I'm going to go from here to here, that's 90, from here to here is 180. So that's actually going to put us in the third quadrant. And that's going to be theta plus pi. Or plus 180 degrees, however you want to look at it. But the main thing is that the cosine, when I go 2 quadrants, goes from a positive here, cosine is now a negative over here. So that means that if cosine of theta is a positive 0.7, if I go 180 degrees more, that's going to be a negative value. So that's how this question was. It's a question about sines. Now what we're going to do is put all this information together and answer a couple questions. So we know that sine of theta is the same as y over r. And since we're given that to be 12 over 13, we now need to find x. And to find x, we're going to use the Pythagorean Theorem, which is x squared plus y squared equals r squared, or you can memorize that one formula way up there on top. X we don't know. Y squared, or y, we're given it to be 12, and r is given to be 13. So now we have x squared plus 144 equals 13 squared, which is 169. Subtract the 144. I'm not leaving out any steps in case you haven't wondered, or if you have wondered. And square root both sides, and I shouldn't be using, oh yeah, I'm using x, I'm fine. And we get x equals 5. So here's the moral of the story. We have x equals 5, we have y equals 12, and r equals 13. Now we gotta look at this, quadrant 2. Quadrant 2. We know that we have a negative x and a positive y in quadrant 2. So that means we have a negative cosine and a positive sine. So I don't memorize anything except for what I should already know. The only thing I'm memorizing is cosine is x, sine is y. So everywhere I have an x, I'm going to have a negative value. Sine is positive, and r is always positive no matter what. So once I figure out that sine, I'm ready to go. Sine of theta, it's already given to be 12 over 13. Cosine of theta is x over r, and x is negative 5, r is 13. Tangent of theta is y over x, because it's sine over cosine. Y is 12 and x is negative 5. So I'm going to write it as 12 over negative 5, but I don't want the minus sign in the bottom, so I'm going to write it as negative 12 over 5. It doesn't matter where the minus sign goes. And once I have those, I'm ready to do the others. Cosecant of theta is just the reciprocal of 12 over 13, so it'd be 13 over 12. Secant is the reciprocal of secant, or of cosine, I mean. So it'd be 13 over negative 5, but I don't want to write it like that, so I'm going to write it as negative 13 over 5. And then cotangent is the reciprocal of tangent. If it's negative 12 over 5, I'm going to write that as negative 5 over 12. I'm just flipping the numbers and keeping the sign on top or on the side. And that's how we're doing. Let's do one more, just to be so we're convinced. Secant of theta. Secant is the same as 1 over cosine, which is the same as 1 over x. Well, I don't want to say that. Wrong. Well, that is correct. That's the one that's not correct. It is 1 over cosine, and well, I don't want to use that. I don't have to do all that work. Let's just think about it. If cosine, remember all I know is cosine. Cosine is x over r. Secant is 1 over cosine. That's why I want y'all to see. So all that means is that secant is the same as flipping over cosine. So it's r over x. And in this case, secant is given to be 2 over 1, which means we have x equals 1 and r equals 2. We need y. So we're going to find it. X squared plus y squared equals r squared. X is 1, y we don't know, so keep it as y, and r is 2. 1 plus y squared equals 4. Subtract 1, we get y squared equals 3, square root. We get y equals square root of 3. And once we have those, we're ready to find all the values. Maybe. I'm going to write them down. Hopefully I have room. The reason why I say maybe is there's more information given. Sine is less than 0. Sine is the same as y. So, and less than 0 means negative. So where's y negative? It's negative in the third quadrant and also in the fourth quadrant. So which quadrant do we use? Can we use either one of them? No, because now we look at the secant. Secant is the same as cosine. Cosine is the same as x, and this is a positive value. So where is cosine or secant positive? It's positive in the fourth quadrant. So we'll look at the fourth quadrant, and cosine is going to be positive, and y is going to be negative, which means that our y value is negative. We really didn't need to know about the fourth quadrant, but it always helps to confirm. The main thing is knowing that sine is associated with y. So y is going to be negative. So now we can find all of our values. Sine of theta is y over r. So it's going to be negative square root of 3 over 2. Cosine is x over r. X is 2. My mistake. I am making all kinds of mistakes. Learn from my mistakes. X is 1, r is 2. And we already knew that, because secant is 2. If you flip over the 2, you get 1/2. Tangent is y over x. So that's negative square root of 3 over 1, which is negative square root of 3. And once you have those, we can find the others. Cosecant of theta. Flip that over, we get negative 2 over square root of 3. We don't like square roots on the bottom, so multiply top and bottom by that square root of 3. And we get negative 2 square root of 3 on top. Square root of 3 times square root of 3, square root of 9, which is 3. Secant of theta is r over x, which is, well, it's already given, so why am I doing this? It was already given. It never hurts to be sure. And then cotangent of theta is x over y, reciprocal of tangent. 1 over square root of 3, it's a negative, get the minus on top, and multiply by square root of 3. One more now, space. X over y equals 1 over square root of 3. The negative, keep that on top. Multiply by square root of 3. We get negative square root of 3 over 3. And I do believe that that is it.